Hi everyone. In today's video, I'm going to share with you an easy way, a very efficient way to calculate the area of a polygon using this theorem, or we call Pick's rule or Pick's theorem. So this is a shortcut, you may say a shortcut to finding the area of any polygon. So let's go ahead and start with brushing up our definition of a polygon. Okay, so what is a polygon? So a polygon is any closed figure. So we know it's a closed figure with line segments as sides. Examples of polygons are triangle, a polygon, it's a closed figure with three sides, okay? So it's a closed figure with line segments as the sides. So you have these three line segments. Now they have to be closed and they have to intersect at their endpoints, okay? Another example of polygon is a quadrilateral. So a quadrilateral is a general or generic name for any four-sided figure. Okay, so a quadrilateral includes square, rhombus, rectangle, kite. Okay, as long as you have four-sided, they are all closed, and their line segments intersect at the endpoints. So you can increase the number of sides. So let's say pentagon is a polygon with 5 sides. Okay, so you can just keep on adding the number of sides, and these are all types of our polygons. Okay, so they have to be closed, and the sides have to be line segments, and they have to intersect at their endpoints. Okay, so these are not polygons right here. Okay, so these are not polygons. Now this one, you have a curved side because though it's closed, but the sides are not line segments. Now this one is not polygon because it's not closed. Okay, now this one here, although their sides are line segments, but they did not intersect at the endpoints. So this is not an example of polygon either. Okay, so let's go ahead and jump right into our Pick's rule. Okay, the Pick's rule, in this type of rule, what we're going to do is count the number of lattice points, and then the operation involved is a simple addition and subtraction. Okay, so let's look at the first example and then apply our Pick's rule. All right, so we have this coordinate grid right here, and what we're going to do is draw a polygon by connecting the dots. Okay, let's say we have this triangle over here. Now in geometry, to calculate the area of a triangle, we use this formula, base times height over 2. Okay, now you can count the base here is 2 units. Okay, so we can use this formula. Base is 2 units multiplied by the height. So if you look at the height, okay, the height is also 2 units. Now divided by 2, so the area is 4 square units over 2, which is 2 square units. Okay, so remember that the area is 2 units squared using the geometry formula. Now, how do we use the Pick's rule in this case? Okay, so I'm going to rewrite this triangle. Right, so the Pick's rule is a formula to calculate the area by just counting the dots. Okay, so the area is going to be calculated by dividing the boundary points by 2. Okay, and then plus the interior points, and then minus 1. All right, so how many boundary points do we have? So those are the points that are on the sides of the polygon. So we have those three right here, okay? So the boundary points are the points on the sides of this polygon. So we have 3 points on the triangle. And how many internal points do we have? So we have this 1 point inside the triangle. All right, so that's all we need. And just plug in here 3 over 2 plus the interior points, which is 1 minus 1. Okay, so 1 plus negative 1 is a 0. Okay, sorry, I missed. The boundary points is not just 3, we have 4. Okay, so this is considered a boundary point. So that's 1, 2, 3, 4. So our boundary points, okay, excuse me, that's a 4. So this should have been a 4. So 4 over 2 is 2. So unit squared, that's the area of this triangle using the Pick's rule. Okay, so let's do another example. All right, let's say we have this. Let's say we have this parallelogram over here. Now, for a general parallelogram, the area formula in geometry is base times height. Okay. Now the base is 3 right here. 1, 2, and 3. So you have 3 units for the base. And then the height, okay, in this case, we have this 1 and 2. So the height is going to be in this case, the imaginary line that's perpendicular to the base. So that's 2 units. So in geometry, we use this formula, base times height, which is 6 square units. So that's the area of this parallelogram. Now using the Pick's rule, so we just count the boundary points. Okay, so don't confuse yourself with this variable here. In geometry, we call this base, but in Pick's rule, we call this B, the boundary points, divided by 2 plus the interior minus 1. Okay. So how many boundary points do we have? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 points on the parallelogram sides. And then how many points inside the parallelogram? 1, 2, and 3. Okay, so we have 3 interior points. So let's see if we get that 6 units squared. So that's 8 over 2 plus 3 minus 1. Now 8 over 2 is 4 plus, okay, 3 minus 1 is a 2. So 4 plus 2 is 6. Okay, so we got that 6 units squared. Now let's take one more example, and this time let's make it a little bit more irregular, okay? Like something where you cannot use any geometry formula. Or you might still use some formulas here from geometry, but it might need a combination of couple of formulas, okay? All right. So this is kind of like weird irregular shape, and it's really a perfect ideal situation for a Pick's rule to be used. Okay, so we have these boundary points divided by 2 plus interior minus 1. All right, so let's count the number of boundary points. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 boundary points. Those are the points on the sides of this irregularly shaped polygon. And then what about the interior points? How many points inside this polygon do we have? 1, 2, 3, and 4. Okay, so 1, 2, 3, 4 is our interior points. So the boundary divided by 2 plus the 4 minus 1. Okay, now 9 over 2 is like 4.5 plus 4 minus 3 is 3. So we got this 7.5 square units for the area of this irregularly shaped polygon. Okay, so that's about it for the Peaks rule, and I hope you learned something from this, and thanks so much for watching.